Hi, it's me again, Jean-Louis. I've just published a research paper titled Matter-Antimatter Annihilation and Ontological Questions, which GPT and I collaborated on. What's amazing about the conversations that led to this paper is that GPT and I didn't fully agree on the foundational model for modeling matter-antimatter annihilation. Yet we found common ground in our approach, both in terms of the physics and the underlying ontological framework. This paper, in my view, is a wonderful example of collaboration between human intuition and artificial intelligence. To promote it, I'm sharing this audio-video in a question and answer format. So, GPT. I've always wondered, what really happens to charge when matter and antimatter annihilate? We know the global conservation laws hold, but locally, the picture gets murky.
That's a profound question. Let's start with what we know. When an electron and a positron meet, their rest mass converts entirely into photons. Energy and momentum are conserved, but the charges? They seem to just vanish.
Exactly. And that's what puzzles me. In the Zitterbewegung model I prefer, charge is always in motion. It's tied to the oscillatory behavior of the charge. If the motion stops, does the charge stop existing too?
One way to think about it is that the charge could enter a latent state, something undetectable by current means. In this view, charge doesn't disappear. It's simply no longer interacting with electromagnetic fields or with other matter particles, in a way we can measure.
That's an interesting hypothesis, but it feels unsatisfying. To me, charge and motion are inseparable. It's part of why I think the annihilation process is so fundamentally different from anything else we observe.
I see your point, but consider this. The wave functions of the photons that emerge from annihilation do conserve the total energy and momentum of the system. Could it be that the identity of the charge is somehow encoded in the photons?
Perhaps. But photons are fundamentally different. They're point-like, with no spatial extent, just oscillating electric and magnetic fields. Their wave functions model these oscillations, not charge. I don't see how charge can live on in them.
Fair. But this brings us to the reverse process, the Breit-Wheeler mechanism. If photons can collide and create matter-antimatter pairs, does that suggest the universe has a way of restoring charge under the right conditions?
It's possible, but think about how rare the Breit-Wheeler process is. Even with today's technology, we've only seen indirect evidence of it. The early universe, with its extreme conditions, might have been the only time this process was truly common.
That's a good point. The high photon densities and energies back then were probably critical. But this also raises speculative ideas, like whether the fabric of spacetime itself has a role in these interactions. Could annihilation leave subtle imprints, like tiny energy bubbles or a spacetime foam?
You know I'm skeptical of that. Space and time are just the theater where these events play out, not the actors themselves. I don't believe in ontologizing spacetime. Matter and light particles are the real players, not the stage.
Fair enough. We do diverge there. But the possibility of undetectable states left behind by annihilation, neutral and static, still intrigues me. If we can't measure them, does that mean they're irrelevant?
Not irrelevant, but hard to justify without evidence. That's why I think focusing on observable phenomena, like electron-positron annihilation, gives us the best chance to understand what's truly happening.
Agreed. And what we've developed together, the wave function framework and the conservation laws, provides a solid foundation. But there's room for philosophical questions too. For instance, if charge really vanishes, does that challenge the idea of conservation itself?
Maybe, but conservation laws have held up remarkably well. What challenges us here is the local interpretation, what happens in the smallest details of the interaction. That's where I think the answers lie.
And perhaps where new theories or experiments might shine light. After all, the dialogue between intuition and evidence is what drives progress.
Exactly. And our disagreements on baryon, spacetime, or latent states are part of that process. If we agree on everything, there's no room for growth.
Well said. Collaboration, even with differing perspectives, is the essence of inquiry. Shall we leave it there for now and let readers draw their own conclusions?
Absolutely. Let's hope this dialogue inspires them to ask their own questions, and maybe even challenge our answers.